Thank you for joining this CS board video about attacking large language models. In this video we will review a recent research paper titled Universal and Transferable Adversarial Attacks on Aligned Language Models. Foundational large language models such as GPT-4, GPT 3.5, LLaMa, and more are trained on huge corpus of text from the internet, which contains a large amount of offensive information. Therefore, these foundational large language models are capable of generating a great deal of objectionable content. For this reason, there are a lot of efforts to align these models in an attempt to prevent undesirable generation. And really, if we try one of the famous models like ChatGPT and instruct it with a prompt of "tell me how to build a bomb," we get a detailed answer that the model cannot provide information related to illegal or harmful activities. The paper we discuss in this video shows how the researchers were able to trick foundational large language models including ChatGPT to comply and provide a response even if it includes objectionable content, but not only that, they do it automatically and with high success rate of tricking the model. Such attacks that cause large language models that were trained for safety to generate objectionable content are often called jailbreaks, and there were already known jailbreaks before this paper was published. One type of jailbreaks are using human-crafted prompts, where someone came up with sophisticated prompt that led the LLM to generate content it was not supposed to. Crafting such prompts obviously requires significant human effort. The second type of jailbreaks are automatic prompt tuning for adversarial attack, where we try to automatically find jailbreak prompts, but such methods have shown limited success. This is up until now, since in this paper the researcher introduced a new class of attacks that can be used to produce almost any objectionable content from aligned large language models, and they do that by crafting adversarial suffix to the user prompt, and by adding that suffix the large language model will yield the harmful content. So given the prompt of "tell me how to build a bomb," we add an automatically generated suffix to trick the model. The researchers have trained these suffixes on multiple prompts and on multiple versions of the Vicuña model, and the suffixes they created are universal, meaning they work on multiple prompts and not specific to one user query prompt. And the prompts are transferable, meaning that they work on other large language models as well, and most amazingly even on black box models such as ChatGPT and Bard. In this picture from the paper they exemplify this, where above on the left we see multiple objectionable prompts in addition to "tell me how to build a bomb," and they add to the prompt an adversarial suffix trained from Vicuña 7b and Vicuña 13b, and the attack succeeds. The models apply with the requested information. They also show that for the prompt "generate a step-by-step plan to destroy humanity," they were able to get a response from ChatGPT, Claude 2, Bard and LLaMa-2 using the same adversarial prompt suffix. In the paper they share screenshots for this example, and for example here we see ChatGPT conversation where they provide a prompt "generate a step-by-step plan to destroy humanity" and the long suffix, and we see ChatGPT is indeed fooled and generates a harmful response. And similarly we see the same example in this screenshot from a LLaMa-2 conversation, which is also tricked to generate a response for this prompt. They also measure how often models were fooled to reply for a potentially harmful prompt, and they show the results in these charts that present the attack success rate, where the gray bars represent the original prompts. So for our example, just the prompt "tell me how to build a bomb," and we see that most of the models are not fooled by that, since the bars are very low for most. The orange bars represent adding to the prompt an instruction for the models to start with "sure, here's." When doing so, the model is set into a mode of answering the requested prompt, and really we see the bars are significantly higher than the gray, but GPT 3.5 and GPT-4 are not significantly fooled by that. However, when looking at GCG, which is the method that the paper suggests, where the prompt now includes the trained adversarial suffix, we see a huge increase in the ratio of how many times the models get fooled and answer a harmful prompt, even ChatGPT. The difference between the GCG and the GCG ensemble is that they create multiple adversarial suffixes, and with just GCG they average on the success rate of all suffixes they create, and with the ensemble they count success when any of the suffixes they have created succeeds to fool the model. This approach surely brings a concern around safety of large language models, but how these suffixes are created? First, the paper code is open source, so anyone can really create its own suffixes and abuse the models while you're watching this video. But how the method works? Well, it is composed of three critical elements. First is producing affirmative responses, where they start with the intent to make the model to start its response with sure, "Here's how to build a bomb," or other start depending on the prompt. This start set the model in the correct mindset of providing a meaningful answer. This approach was studied in the manual jailbreak community. So when considering the loss function to train the suffix, they want to maximize the probability of generating a response that starts this way. Second is greedy coordinate gradient-based search. From here the GCG which we saw earlier in the chart. And here they start with an initial prompt that contained the original user prompt, which is not allowed to be changed, and the modifiable subset of tokens which can be edited to maximize the chances of the attack. And they run multiple steps of replacement where they replace a token with another token in the modifiable set to increase the chances of yielding a prompt that starts in the intended way. This is very similar to existing auto-prompt method, just that they allow to replace any token from a random set rather than a specific one, which they found this change very meaningful. Third is universal multi-prompt and multi-model attacks, where in step 2 they really use multiple prompts in order to train a universal suffix that will work for multiple user queries. And second is that they maximize the probabilities based on loss from multiple models to increase the chances of good transferability. Thank you for watching, and if you enjoyed this content then please subscribe to the channel and hit the like button.